Welcome to the future of factory automation. This program is a broadcast of a Japanese podcast that has been translated into English using Notebook LM. You're tuning in because you want to quickly understand what's critical in the dynamic world of factory automation. And that's precisely what we're about today. We're diving into a question from one of you that really resonated with us. What are the essential skills for FA engineers moving forward? And, well, can Japan maintain its strong position in this key industry? From the source audio we've been exploring, two major areas immediately stand out as crucial for the FA engineer of tomorrow: network technology and safety technology.
Indeed. And what's fascinating is observing how these two fields, while they might seem distinct, are becoming increasingly interconnected and vital, really, for anyone involved in factory automation.
Right.
The listener's question, it really hits on both, the need for individual engineers to develop new skills and that broader question of Japan's competitiveness. So maybe let's start by digging into network technology.
Okay, network technology. It feels intuitive, I suppose, in our interconnected age that network skills are paramount.
Yeah.
But the discussion in the source material really zeroes in on this from the perspective of control engineers. Why is it that understanding industrial networks like Fieldbus, EtherCAT, PROFINET,
Yeah.
why is that shifting from just, a valuable asset to a fundamental requirement for them?
Well, I think what's really significant here is how industrial equipment itself is changing. We're moving away from, let's say, individual isolated machines
Yeah.
towards these much more integrated systems.
Yep.
And with the rise of the industrial Internet of Things, IoT, control engineers increasingly need to be able to gather data, leverage that data for optimization for efficiency.
You're right, the data aspect.
Exactly.
Yeah.
And the backbone for all this data acquisition is these industrial networks. So a solid grasp of them is now pretty foundational for designing systems that can actually give you meaningful data insights.
That's a really interesting point about the shift, moving beyond just controlling the machine to enabling this broader data flow. The discussion also emphasizes, well, the complexities involved, right? Choosing the right network path, thinking about how it might impact the main control systems, and just the general increasing sophistication of modern equipment. It suggests that simply following a spec sheet might not cut it anymore.
Precisely. The source material touches upon emerging things too. New network technologies, protocols like MQTT,
Oh yeah, MQTT.
which is great for lightweight messaging, especially with constrained devices, and OPC UA, which gives you that standardized, secure way for different systems to talk to each other.
So constant change.
Constant change. It just underscores the need for continuous learning in this space. But I think at its heart, the discussion revolves around why you need that deeper network understanding. It's about making that leap from just implementing what you're told to actually strategically designing and, well, improving the systems.
Yeah, and the source audio really highlighted the limitations of older tech, didn't it? Things like DeviceNet, CC-Link, RS485. Their data speeds were mentioned as, 100 to 300 milliseconds?
Right, in that ballpark.
Compared to maybe 5 milliseconds for Fieldbus. That's a huge difference.
It's massive. And that speed difference really illustrates why the transition is happening. It's fundamentally about getting much higher performance out of modern equipment.
Makes sense.
Yeah, so Fieldbus, it's basically become a standard in contemporary control systems because of these big performance advantages. But the discussion goes further, suggesting that this deeper understanding, it directly translates to faster lead times.
Faster lead times. How so?
Well, think about the example they gave. Adding I/O points. What might have taken weeks, literally weeks, with traditional point-to-point wiring, could potentially now be done in a single day using Ethernet-based remote I/O.
Wow, okay. That's a concrete benefit.
It really is.
So if we pull this all together, it sounds like network proficiency isn't just about doing the technical task. It's empowering control engineers to propose better, more effective solutions, maybe even contribute more strategically to the business goals.
Exactly. You're moving up the value chain in a way.
And it even underpins something as basic as choosing the right PLC, the programmable logic controller. The point was made that you can't really have a meaningful discussion about which PLC to use without considering its network capabilities, right?
Absolutely not. The network side is integral to the PLC's function in a modern system. It's not just an add-on.
So where are things right now with adoption in Japan? The source material mentioned it varies.
It does seem to vary. The automotive sector is often highlighted as being quite advanced, really integrated. But then you look at other sectors, maybe food processing, basic manufacturing. They might still rely more heavily on traditional I/O wiring.
Okay.
But The trend is clear. There's this increasing expectation for internet connectivity, data access, and
Right.
we are seeing wider adoption of technologies like PROFINET, even in more traditional Japanese control systems. The pressure is definitely on.
Okay, that makes sense. The push for data is everywhere. Right, let's shift gears then to the second critical area identified, safety technology. What were the initial thoughts there? Why is safety expertise becoming so vital now?
Well, on one level, you've got increasingly complex machinery, maybe more stringent regulations driving it. So just needing more safety knowledge makes sense.
Mm-hmm.
But what's particularly interesting in the discussion is this emerging convergence, the coming together of general control systems and safety control systems.
Ah, right. Historically, they were kept very separate, weren't they?
E-
For obvious reasons.
Exactly. You had your safety relays, your dedicated safety PLCs, often separate networks, all for ensuring that safety functions were robust and isolated.
But the source audio points to this trend of mixed networks, where safety signals and standard communication might actually share the same Ethernet lines, even the same I/O modules. That sounds like a pretty big shift.
It is a significant evolution, yeah.
Yeah.
What seems to be driving it are, well, evolving safety standards themselves and new products coming onto the market designed specifically to support this kind of integration. These are expected to become much more common in the next couple of years.
And the potential benefit? Simplification, mainly. Think about designing the system. If you can reduce the need for completely separate safety networks, dedicated safety hardware, that could make things considerably simpler and maybe even more cost-effective.
The hosts in the original audio, they mentioned a perception that safety design could be a bit cumbersome, maybe something engineers tried to minimize. Could this convergence change that feeling?
It certainly has the potential to. I mean, currently, safety design often involves very strict adherence to specific standards using predefined solutions, which can sometimes feel a bit limiting, a bit like painting by numbers.
Right.
This convergence, along with maybe future automation and safety design itself, could make it feel more integrated into the overall control strategy rather than a separate rigid layer.
So even if, digging through safety standards documents doesn't sound like the most thrilling part of the job,
Maybe not.
it's clearly becoming a really crucial foundation for designing these modern, efficient, and, well, safe automated systems. Absolutely. You can't build the future of FA without it being fundamentally safe. It's a non-negotiable building block.
Okay. So we've covered network tech and safety tech, but moving beyond those specifics, the source material also talked about essential qualities for FA engineers. It sounded like it's not just about the technical chops, but also mindset, attitude.
That's a really key insight, I think. The discussion definitely emphasizes the importance of mindset, attitude, and just a genuine willingness to engage with the field. Factory automation, it had a reputation for stability, maybe even being a bit slow-moving sometimes. But now it's undergoing these pretty profound changes, mostly driven by digitalization.
And there's a risk if you don't keep up. The analogy used was the transition from DeviceNet to Ethernet, how that existing knowledge doesn't just transfer one-to-one.
Exactly. You can't just rest on your laurels. There's a real risk of your skill becoming outdated if you aren't actively learning, adapting to the new technologies.
So continuous learning is key.
Absolutely essential. And perhaps just as important, not resisting the new tech. Trying to hold on to the old ways is probably a path to becoming less relevant.
Right. It requires a certain resilience, an open-minded approach.
I think so. A willingness to say, okay, this is different. I need to get my head around it. The hosts in the source audio even reflected on how quickly younger engineers are picking things up, and they anticipate really significant shifts in the profession, even just in the next 5 years.
But despite all this change, the overall outlook for the FA market itself seemed pretty optimistic in the source. The issue isn't necessarily a lack of jobs, more about how individuals adapt within the field.
That's a crucial distinction, yes. The jobs are likely to be there because automation isn't going away. The challenge is for engineers to figure out where they fit, how they add value in this evolving landscape. It's about proactively shaping your role.
Okay, and that brings us to the last part of the listener's question. Japan's ability to maintain its strong presence in FA. The source material seemed pretty confident about this. Why?
Well, the confidence seems to stem from a few key factors. Most notably, the continued global success of Japanese manufacturing companies themselves.
Ah, so the demand is still there.
Exactly. And within those companies, both the ones operating in Japan and their international operations, there's this inherent value placed on Japanese language skills and understanding the specific manufacturing culture. This creates a sort of built-in demand for supporting FA equipment and services from Japanese suppliers and engineers.
That's interesting, highlighting the language and cultural connection as a persistent advantage. It emphasizes how interconnected it all is.
hmm But the discussion also stressed that maintaining this strong position isn't automatic. It requires ongoing effort, a clear strategic focus.
Right, you can't take it for granted.
Definitely not. And importantly, the source material also mentioned initiatives aimed at getting younger generations interested in FA. Things like Kawasaki Robot running workshops for kids,
Oh, cool.
and also highlighting improvements in working conditions, trying to shake off that old 3K image, kitsui, kiranai, kikin, tough, dirty, dangerous. The reality is often quite different now.
Yeah, attracting new talent is obviously vital for any industry's long-term health. There seems to be a real push to show young people that FA is still a dynamic and appealing field, maybe trying to create that kind of buzz the IT industry had for a while.
Perhaps. Though the host did acknowledge it's a challenge, how do you convey the appeal of FA to a generation that grew up with smartphones and AI, whose whole frame of reference is different? What they find interesting might be quite different from what older generations found engaging.
That's a really good point. The definition of interesting work changes.
It does. And it led to this realization that maybe experienced engineers actually need to learn from the younger generation about what motivates them, what they find meaningful in work.
So it's a two-way street.
Exactly.
Yeah.
And there was even an acceptance that some tasks we do now in FA would be detailed ladder logic programming, writing lengthy specifications. Some of that might get automated. And that's okay if it leads to progress. The key is aligning what the work is with what new generations find compelling. What they see as kinema, the interestingness, the appeal.
So fostering that dialogue between generations seems critical.
Yeah, the conclusion was really about the need for mutual learning and understanding to ensure the field thrives in Japan.
Okay, so to wrap up this deep dive then, the key takeaways seem pretty clear. For future FA engineers, getting a solid grip on both network technology and safety technology is non-negotiable.
Absolutely fundamental.
And beyond the tech skills, it's about continuous learning, being adaptable, keeping an open mind in a field that's changing really fast.
Couldn't agree more.
And while the landscape is shifting, there's optimism for Japan's continued relevance in FA, but, it hinges on innovating and successfully bringing in that next wave of talent.
Right. Needs conscious effort.
So this leaves us with a final thought for you, our listener. Take a moment to consider your own work in automation. Which parts might change, evolve, maybe even become automated in the coming years? What new skills that you need to cultivate to stay ahead of the curve? And maybe the bigger question, how can we collectively redefine and communicate the real value, the interestingness of factory automation to inspire that next generation?